Okay, so today we're going to be talking about the last two assignments that are here in Module 4, which are going to be an application of sheet metal. And you're going to notice that these are going to be specific to our Can Crusher project. Assignment 4C is worth 120 points. And this is kind of a blanket, depending on how you decide to design your Can Crusher. And I'm going to talk about some liberties that you have on the one that we have here. It'll kind of depend on how many parts you have. So I'm giving it a blanket 120. I did it in 8 parts and I was figuring 15 points a part or a model in there. Then that's how I kind of came up with it. But if you end up having 7 parts or 9 parts, it's still just going to be a blanket 120 points. Does that make sense? Okay. So let's take a peek here. This is just part models, no drawings. Okay. So we're focusing really on doing sheet metal, if you would. So the assignment says here, you're going to make the part models for each one of the Can Crusher parts in the Can Crusher assembly. Make sure attend the demonstration lecture for this information. So that's what we're doing now. So the process that I have on here, and this really isn't intended for a step-by-step, but the things here that are important are, number one, you're going to reverse engineer each of the Can Crusher parts. And when I say reverse engineer, you're going to be measuring them up. Okay, we don't have any drawings. We don't have anything to really go on this, except we have a put together Can Crusher, and I have it underneath my camera right now. So let me just pull it up really quick. So here's our Can Crusher, okay? Now, it is a physical part here in the room. So if you are virtual, you're going to have to make a trip out to WCTC to get measurements and or pictures so that if you wanted to model off campus, you can, okay? But you will need to, physically measure this part. And we have all the measuring equipment, and I have 8 different eight Can Crushers here. So there's plenty. We have to share. We don't want to hold on to it if we're not using it. So just making sure everybody has a chance to get their hands on one. So this is our Can Crusher. So making each of the parts in our Can Crusher. Okay, so we're going to just model them. Make sure when you're doing these, you have to have everything fully defined. And I'm going to kind of show you, there are going to be some places that when you put in like for instance, the form tool, I'll show you the process that I found to be easiest, but then you have to go back in and you have to define the position. So I'm gonna show you what I mean by that. But all of the sketches need to be expanded so I can see that everything is fully defined. That's still very important. I'm going to say optional, rename the model tree features because I can't expect you to do something that I don't think I did. I went through and I did kind of the main ones, but I don't think I was meticulous and did every single one. I hope that that's a good habit that you have. And again, I try to make sure that I do that, but I don't think I was perfect on this. So when we pull up my models, I can't really expect you guys to do that. So optional, but a good idea, always good practice. Number 3 here, then you're going to upload screenshots of the models with including the model tree. So I do want to see those expanded sketches, make sure that there's no negatives there. If there are negatives, I'm going to take points off. Try your best to get those fully defined. Okay. And if you need some help with that, let me know. I did say here again, no detailed drawings are needed for this. And then always position the model so that I can kind of see the best views of as many features as possible. So again, 15 points each. I have 8 in my model, in my assembly, but if you end up having, 9, 7, that's fine too. Okay, so the standard 2 attempts. So let's look at then the other assignment, which is assignment D. This one's only worth 20 points because this is the assembly model. Okay, so now you're going to take those part models, you're going to bring them together, you're going to put them together in an assembly format. And here again, no assembly drawing is going to be created, but you want to, you don't have to, I want to see the model tree so I can see that all the parts are in there, but you don't have to expand anything out and you don't have to fully define each one of the items in the design tree, just because as we know, they don't have to be. Sometimes we want things to move around. And if we fully define them, we don't get that opportunity to do that. So it's not as critical in the assembly as it is obviously in the parts. So these are the 2 assignments. So what I'm going to do now is I'm going to switch over to SolidWorks, and I'm actually going to pull up my model first. Okay. Now I'm going to kind of go back and forth underneath the camera here. As I look at this part, so the function of this, I've got my handle here. and it's going to pull down. I put my can in here and it's going to crush it, right? This would be mounted on a wall, obviously. Okay. So that's how the mechanism works here. Now, as we look at the design, this design is symmetrical. Okay. So if I would put a line down the middle here, it's a mirror image on either side. Okay. So recognizing that, what that means is when I did, or what that helped me to do when I did my model here, you're going to notice that because it's symmetrical, every one of my parts is mated to line up with the right plane. Okay. That means that because I have that line of symmetry here, or that plane of symmetry in my assembly, I thought when I set it up, when I did each one of my parts, they all have that right plane going right down the middle and all the parts are symmetrical. So that way, when I brought them in, I could line up that center plane on my assembly and on the individual parts. And that's one of the mates for every single thing that I have. Okay. So keep that in mind as you're creating the models of each one of these parts. Have a center plane, because then it's so much easier than trying to, line things up otherwise. Okay. So, so that's something to consider. Yep. Okay. All right. That's what I wanted to say about assembly. All right. So then when we'll kind of come back to this again, then what I wanted to do was to go into the individual parts and just kind of give you an idea of how I approach things, as well as maybe some things that came up that I want you to be aware of. So we're going to look first at the first part, and I created them with part numbers. I kind of expect you to do that at this point. We've been doing this with all of them. Don't name them names, call them part numbers. I know we're not going to be creating detailed drawings or an assembly drawing, but still, it's kind of how you save things. So I called my assembly model 40,000, then this is 40,001, 2, 3, and so on. Okay, so this is my first part. So this is kind of that plate, that main plate that everything is getting assembled into. So how I approach this. So you're going to be starting off with a base sketch, okay? And the base sketch in this case is going to be similar to that tutorial you did, where you are actually going to do the profile looking down the center here. And what you're going to do is you're going to line it up. No, it's this one. You're going to line it up so that the origin is right in the middle here. Just like you did, if you haven't done that tutorial yet, that first tutorial, the post bracket or something like that, the post, what's it called? I don't know, it doesn't matter. But this is how that was set up, okay? So notice that the origin is right in the middle and I have everything centered here. And then what you're going to do is you're going to create your base flange off of that, okay? And so then I'm going to exit this sketch here, and you'll notice that then I just have a generic kind of C channel, going the entire length, okay? Then what I did is you are going to see here, then I added my next edge flange, okay? Every one of the bends that I have here is an edge flange. It is nothing else, okay, in the sheet metal area. So then this one was an edge flange, and just so that you're aware, if you haven't already done it, and you'll notice this in the tutorial, you need to go up and you need to add a tab for sheet metal. Okay, that's where all the functions are. Otherwise, you're going to have to be, I think, searching for them, and that gets really kind of old really quick. So make sure that you go up, right click in the top here, activate your tabs, and then make sure that sheet metal is there. And then, so in the sheet metal, the edge flange was what I did for everything on this part. Okay. Now, once I got that in place, then in the sheet metal area, and I'm going to be honest, I don't know if it matters, but because it's sheet metal, I kept it in sheet metal. So you're going to see in sheet metal here, you have an extrude cut, like to put holes and such in. It's the same function as the extrude cut at the feature level, but I did an experiment that if to do it at the feature level, and I kind of wish I would have, that if it makes a difference if I put it in the sheet metal. I kept everything that I did on any one of my parts feature-wise in the sheet metal mode. Does that make sense? Okay. So, so these holes went in as extrude cuts. I did not use the hole wizard. Okay. I used it through here as kind of just a traditional cut feature. Okay. So all three holes on the top and then one on the bottom. And again, those sizes and locations would be measured, on the part itself. So you would be, using our measuring tools in here and, figuring out as close as possible to what that is. On that note, I do not have a master can crusher that I consider the standard for what your dimensions are going to be. You are going to be taking a calipers. Let me grab one. And or a scale, okay? And you're going to be estimating this stuff. I mean, you're going to need to get as close. So if I have a calipers and I'm trying to figure out how far apart these are, I'm still eyeballing it, okay? But then what you want to do is you want to use kind of your common sense of, all right, if I'm measuring 1.084, it's probably about an inch and a 16th, or maybe it's an inch. Okay, so round these things and make the numbers so that they make sense to the units that you're working with. Okay, so you don't want them to be obscure like numbers. So as long as you're nice and close, but I'm not gonna grab your can crusher and then look at your dimensions and compare them back. Okay, we want this to function, and really it's about practicing using measuring tools, using that information, translating them to models, and using the sheet metal components. Okay. All right. So those are the holes. So once I got all of those features in place, the only thing left were these forms at the bottom. Okay, the forms at the bottom. This form is almost identical, just different size than what we have in our tutorial, the second tutorial. Okay, so in this case, what we're going to do is you're going to make a form tool that is then going to fit on the inside here and bump this out. This bump out, and I know it's not going to be easy to see underneath my camera here, but at the bottom, where our handle attaches, you can kind of see there's a raised dome that comes from and I don't see it here either because there's a part in the middle, but there's a raised dome there so that this handle kind of is out from the side of that plate. Okay. So rather than putting in a shim or or washers or something in there, they bumped that out, I'd like to say, but you have to use a form tool to do that. Now, something I want to say about form tools are not going to be what they actually use in industry to make it. The form tool is there to tell SolidWorks what's the form that you need to create on the side of the part. Okay. So after you make that form tool, and we'll talk about form tools in a little bit, what you're going to be doing is bringing it in here. I'm not going to talk about form tool just yet because I'm going to talk about form tools in general, and then we'll show how to put it on a part. But this was put in with the form tool. I called it a side bump, and that's what it was. Yeah, as you can see here, I didn't do the greatest job, like I said, to rename things. I was more just making sure I was getting things in there, and I didn't get a chance to go back. So I'm not going to hold you to that standard. But again, good practice if you do. All right, so I don't know that there's going to be any questions right now, but that's my approach. And I'm always happy to bring up my models during our time that you're working, and we can kind of work through things if you have any questions or see how I approached it. Okay. There are other ways to approach things, so don't feel like it's the only way. Just want to make sure I hit everything here. Sheet metal. Okay. All right, then we'll look at our next part here. The next part, number 2. Okay. This one is the top movable crusher, if you would. Okay. So this one, how I approach this one I did a little bit differently. Even though it has this profile, you would think, oh, you're going to kind of approach it just like the tutorial in that last part. But if I look down the side here, I don't remember if it must be a top view. When I look down the side, notice how one set of flanges is at one depth and another is at another. So it's not really a clean C channel that I can send, for the full length. So how I approached this one, it was a little bit different. On this base flange, let me go here. what I did was I made it a flat sheet. The profile of the top of that movable plate, okay? So this ended up being just a base flange, a flat sheet. And this was where I defined what the thickness of my sheet metal was. So I used everything on here as 16 gauge, everything, every single piece, okay? I felt that was the closest one, so I used 16 gauge. If you find that you feel it's 17 gauge or something different, I mean, that's fine, but that's what I used, okay? So I did that first, okay? I'm gonna exit the sketch. Then what I did after that, I made an edge flange on this side, okay? And this was the one that was closer in, okay? So I did that one. And if we look, here's the sketch for one and then the other. Then what I did is I did the other edge flange here, okay, on either side. And then I put the holes in. And again, I did the holes in the sheet metal tab as opposed to Hole Wizard or outside in the feature. And then I added a form tool. And when you get to, having the can crusher in your possession, if I look here, there's kind of a little form there. Okay, so that represents that. And then we'll talk about form tools in just a little bit. Then my next piece, open this one. Oopsie, I have it open. Sorry. My next piece is number 3. And this is the bottom stationary plate. Okay, so it has that very same form as the top one did. But then this one is going to fit on the inside, and it actually gets a little tack weld. You don't have to represent tack welding because it's actually going to be riveted first and then it gets tack welded in place. But this is that part. Again, complete base flanges. I started with edge flanges. I started with, again, just like the last one, I made the profile here as my sketch. Okay. Made it and identified my sheet metal as being 16 gauge. And then what I did was I made an edge flange on the front here. So it's kind of like the perimeter of where the curved edge was in the front. Now, you'll notice that there's this radius out front. Guess how I measured that? I didn't. I made it look good. That's what I did. Okay. All it is on the front here, it is a radius. Now, if it was functional that it needed to mate with something else, I probably would take the time to try to figure that out, but it's not. It's the front edge. And again, as long as you make it look close, then that'll be fine with me. I did make my front radius here to be the same as the front here so that, technically they kind of match up if you would, and they look like they represent each other. But again, you don't have to try to be like, how do I measure that? How am I going to figure that out? Just make it look good. Okay. That's some of the liberty that you can take as the designer. Okay. Right. Here. So this was an edge flange. And then the next one here was an edge flange. And then I mirrored this one to the other side. Okay. Mirrored it to the other side. Then I did the holes again through the sheet metal tab and then the form tool at the top. And again, all 16 gauge. Oops. Open. The next piece here, we did talk about this a little bit the last time we were together when we introduced the project. I did do a design change here, and you can choose to do what you want. If I go underneath and I look at the side plate here, this connector, okay, there is a rounded edge here. And if I can get this underneath here, I think you can see it right about there. There we go. You see how there is a radius here that kind of mimics a half of a circle. And it's a form because that portion is, if you would, like bent down. There's a jog in there, okay? I tried. I was like, I can't get it to work decent. I know there's a way to do it, but I just kind of ran out of determination. So what I did instead, which again, this is another liberty I took, and feel free to do the very same thing, is instead of having the radius, I just made it a line straight across. And instead of a flange or an edge flange, this is actually a jog, okay? This is a jog. So there is no edge flange on this one. So if I look here, I've got two jogs. I will show you the sketch for the jog. It's really, I mean, you got to be careful with this one. It's very complicated. It's a line. That's it. That's it. You just have to define where that is and make sure it's on each edge. That's it. And that's why I'm like, wow, I think this will work. And really all it is it's making the one side at a different height and depth than the other. And then when once you have that sketch in place, you select it using this jog function in the sheet metal. And then when you do the jog function, I'm going to edit this, they're going to have you pick a face. And I'm only telling you about this in a little bit more detail because this is not in the tutorials, okay? You have to pick a fixed face. And that's going to be the part that's going to kind of stay in place. And then the jog is going to go up here. Now, as far as you know, what you're doing here, this is the blind jog, and you can switch the direction by just toggling this, just like on other functions that we see in SolidWorks. The depth dimension for the blind, this is just really how deep it goes or how high it's going to go. I did a 30-second, okay? That's what I found seemed to work. And then my jog was not 90 degrees. I did 45 degrees, okay? So 45 degrees. And then it's a 32nd of an inch, okay? Now, this is going to go in one direction on one side, okay? Then you have to do a jog in the opposite direction on the other side. So I'm going to go, yeah, that's okay. And then if I go to jog 6 here, or jog, must have done it a couple times, then notice that if this one was going up on this side, then this one is going to go down on the other side. Okay. And this is a reversible part then for us. We'd only have to make one of these. I'm going to call it an arm. Okay. The straight arm there. And then we just flip it on the other side. You don't have to make two of these. Okay. And the same thing, 32nd of an inch blind, jogged, or I toggled it to the other side, and then a 45-degree angle here. Okay. All right. Yeah. Good. Okay. So, so that's that part. That one doesn't need any form or anything like that, form tool. It's just going to be the two jogs on either end. Okay. So any questions on that one? Okay. Yeah, it's actually pretty straightforward. The next one that we're going to look at here, see, is going to be the longer arm. Okay. The one that we actually use to, you know, operate it. Now this one, this is two separate parts. There's one for one side and one for the other because we have to put this form from the inside out, if you would. Okay. So as we look at the arm here, and hopefully you can see it, I think you can, like here-ish. You kind of see how there's that form. So on the outside, it's pushing out, and on the inside, it's like caved in. Yeah, there you can see it pretty good. Okay. All right. So there's two form tools on this one part. There's a short one right here. And then there's the longer one that goes along with a little radius here. Okay. Guess how I measured the radius? I didn't. Nope, I didn't. I made it look good. Okay. So you're going to find sometimes when you're out in industry, you're going to be kind of looking at something, and sometimes people are going to say, well, just make it look good. You know, how do I do this? Well, just make it look good. Okay. And you do, there is an element of you want it to look good. So, yeah, so I just kind of estimated it, and I created the part. So I'll kind of show you my base flange again was just a flat piece. Okay. So no real flanges. It was where I identified how thick the material was. So again, 16 gauge. Okay. Then I put my holes in place for everything. Okay. All 3 holes went in, and again, did it through the sheet metal extrude cut here. And then I added my form tools at the end. Okay. And again, we'll look at that actually in just a bit. So those are the sheet metal parts that I created. Okay. Oh, I will say, this is not the same part. We can't take this part and put it to the other side because of the shape of that form being out and in. So this is two pieces. So I have a 40,005 for one side, and then I had to do a mirror image and put the form from the inside out on the other piece, which is my 6. So now it's the opposite side. So these two are two part numbers. The arm that has the jog on it, that is one part that's just flipped. This one has to be a left and a right, if you would. Okay. Now, the last piece that I have before we talk about form tool is going to be my handle. I think I talked about this the last time, but I'll tell you again. I just made a solid cylinder that has threaded holes in the end here. I think they're 1/4 20 threads, and I think they're about 1/2 or 3/4 inch deep. Okay. And then what I did is I put it between the handles when it was in place, and then I just did a button head screw on either side. Now, the actual assembly, you're going to know, does not do that. Okay. The actual assembly has this like padded cover over the top of a rod that's going through. Okay. And then they have a threaded end coming through and nuts on the end. Okay. You could do that too if you wanted to. That's where you might get a different number of pieces than I have. Okay. And I don't know. I just thought it would be easier. I kind of just did a solid piece here. So that's up to you how you would want to do that. Okay. Again, if you want to duplicate what's here and find something, that's totally fine, and model it that way. That's up to you. Lastly, before we look at form tool, there are rivets holding like the arms in place for each one of these features. So there's 1, 2, 3, 4, I call them short rivets, and 2 longer rivets because this is sandwiching a little bit more material together. Okay, so you've got to have a little bit longer rivet on the 2 on the bottom. Now, as far as rivets, there are none in the toolbox. Okay, so you have to create them, okay, or model them. Very simple. I'll show you what I did. I think I gotta go into one of these. Oopsie. Let me open up. I have a rivet long and a rivet. So my first rivet here, this is the 4 shorter ones. Okay, this is it. Okay, what I did was I went into McMaster-Carr online. I found rivets. They're just standard rivets. It's just a generic standard rivet. And I knew how thick of the material that it had to go through. Okay, so that's one of the things that they identify. And then I also knew the size of the hole that I needed to get through. Okay, and I think I estimated about a 1/4 inch. Okay, so with those 2 dimensions, I picked up my rivet, and they just gave some generic dimensions, and all I did was make the head look like a rivet head, and I made sure that my depth was going to be long enough. So this is just my, if you would, short rivet. I needed 4 of those, and then I did a long rivet for the 2 at the bottom. So it's just a little bit longer on the body here. Okay. I just modeled it. Not a big deal. Keep it simple. Okay. Keep it nice and simple, but make it kind of look like a rivet, right? Make it kind of look like a rivet. And then lastly, the 2 button heads screws came from the toolbox. Okay. So I specified those. So those are the individual parts. Okay. Let's talk form tool. Okay. Form tools. So when you do the tutorial in assignment 4B for the form tools, couple things you have to keep in mind. So let me go here and open up one of my form tools. So when you start a new file for a form tool, it's just going to be a regular file, regular SolidWorks part. Okay. So let me go to my crusher plate open. So, oh, why is that not there? That's really weird. Um, well, I'm not exactly sure, but let me open it up on the drawing then. I was going to open it up here. Yeah, I think.
You might have applied it to the SL.
Um, okay, sorry about that. So the form tool that I created for the bottom bump out here, how you start this is just like you do in the tutorial, is you start just like a regular SolidWorks file. And when you create it, so I want to open that one up. I'm going to go over to, because it's in a form tool format at this time. I think it's the side bump, this one. So I'm going to left click in my form tools here, and I'm just going to open this up for right now. Now, when I created this, I'm going to show you the process I went through. So the first thing that I created was the base. It's kind of like a little block here. And when you do the tutorial for the form tool, you're going to kind of get that terminology of the stop surface, okay? And the stop surface is going to be the part that's going to actually be up against whatever surface you want to put the form on, okay? And then you're going to build the form in front of that. So when you create your base here, okay, and you did this, but they didn't really tell you why you did it in the tutorial, but this sketch needs to be on, I'm going to kind of put it here, it needs to be on a plane. Okay, so pick one of your planes, a plane that makes sense. I usually do it on my front plane, which is totally fine. Now, when you extrude, typically when you extrude this, so it's just a rectangle, and I'm going to extrude it to get my depth here, okay? When you extrude it, you have to flip the direction because you want to extrude back from that surface, okay? Because that's going to be your top surface, and that's going to be the surface that we are going to be putting our actual form on, okay? So always flip that direction so that then we're going to be on the front surface when we're creating our form, okay? So then, and this can just be a generic rectangle that's just going to be larger than whatever the form shape is that you're creating, okay? Now I'm going to go down and I'm going to then create my sketch for whatever, you know, my form is going to be, okay? Now, notice that I went on that front face or that front plane. Okay, so here's my front plane and I came forward. So now what I have here is that plane is identifying my stop surface. You want to do that because when you put this in place, it's going to recognize that stop surface and it's going to put it up against whatever side you want it to be on. If that surface is on the back side of this, it's not going to create the form. Does that make sense to everybody? So just be aware of that. And like I said, they kind of leave that out of, believe me, I experienced it and I'm like, why isn't this working? And I realized, oh, you got to have that stop surface as your plane. Okay. All right. So I just want to kind of save you from having to kind of figure that out. All right. And then once I got that in place, then the next thing you just kind of need to be aware of is you're going to be putting these radiuses on, because when you do sheet metal, you can't have real sharp corners. It's going to always have a bend in it. And when possible, you want to give it as generous as much of a radius as you possibly can. So when you look at 16 gauge has a depth of, or has a thickness of 0.0598, if I'm remembering correct. It's either 0.0598 or 0.0589, one of the two, okay? So when you put a radius on, the radius has to be larger than the thickness of the material. Okay, otherwise you're going to get an error. It's going to say your material is not compatible with this radius. Okay, so make sure that whatever radius you put in here, so when I did my fillet, my fillet's at like 0.1. Okay, it's larger than the thickness of my material, which is 0.059-ish. Okay, all right. So make sure that that's larger. So that's my first fillet. And then you'll notice this split line business. The split line business was in the tutorial. Now, when you do your split line, this is another thing to keep in mind because they didn't, again, make this clear in the tutorial. So if I look at my sketch is on that front plane, okay? Even though there's a surface out here and our gut is always going to be to go on that top surface to make the hole, if you would. No. You've got to put that sketch on that front surface, that stop plane, okay? And then you're going to, if you would, project it up with that split level command, okay? The reason we have to do that is because the split level kind of splits that surface so that it'll know to put a hole in the middle, okay? And that's what you did in your tutorial, except it was that arc, okay? This is now the hole because this is representing where we're going to, on here, we're going to be putting a hole through there. That's representing that right there, okay? So I needed to form and cut. Now, again, this form tool is not going to be used in manufacturing. This is not how they're going to do it. This is just so SolidWorks knows what to do, okay, to represent this. Okay. Is that here? Okay. All right. Then once I do that split line command, okay, so I exit this sketch, it brings it forward to that top surface, okay? I wanted to point that out because that took me a couple times too. I'm like, why isn't it doing it? And I'm like, and then I would do the split line and then I would get an error and I'm like, what? It has to be from that stop plane, okay, or that stop surface. And then once I had that in place, then I put my last radius on. Again, has to be a larger radius than what the material is. And then you have to then convert this to a form tool by going to insert, sheet metal, and then form tool is all the way at the bottom. Here, when you do that, okay, it's already done, so that's why it's not going into it. Let me see here. Whoopsie, this one. Okay. When you do that, you have to identify the stopping surface or the stopping face, which is going to be that face that we identified and that's on our front plane, if you would. And then this one does have that face to remove, and that's going to be the inside of that hole that we did the split on, okay? The split line. So just want to make sure you have that. That's the only one that we need to remove material on as far as any of the forming tools, okay? The other ones we don't have to worry about that with, okay? So let's look at one other one, and that would be on, I'll do it on the arm here, okay? So if I go in and I go to my design library under my forming tools, that's another point. They do say this in the tutorial. Make sure that you save your forming tools in the forming tool directory, okay? You have to put it in the directory. If you don't, then it doesn't recognize it as form tools all the time, okay? I learned that too. So, so you'll notice on this part, I have these two bump outs, right? On those handles, okay? Remember, this is a left and a right. So when I have my form tool here, oopsie, I'm going to open it through here, form tool. I think this is the long. Is this the long? The long. This is it. I'll do open. Yeah. So here's my form tool for this one. You'll notice that I don't have any split lines on this one. So when I do my form tool here, you just don't fill anything in for the faces to remove, okay? Because there's just not anything. All you do is you put in the stopping face. That's it, okay? And again, the same rules. You're going to notice that if I look here, my front plane is the one that's on that surface. So when you create the original base shape, the block, if you would, that it's sitting on, you have to change the direction of that extrude, and then you select that face for the form to go forward, okay? Yeah. Trying to think, I have a couple notes on form tools. Start there, fillets. insert, and then save as a form tool in the correct directory. Yeah. I think I covered everything. Oh, no, I didn't. I didn't. One more thing. So when you pull this into a part, this is what's important. So if I go into a part, and I'm going to go back to that, base, okay? Because here you can see it really well. So when I pull my form tool in, okay, some people have been asking, how do I do that? It's not, I don't think it's really descriptive in the tutorial. So I'm going to pull in my side bump here. So I'm in my form tools directory. Here's my side bump, okay? And all you do is you pull it out, and then you're going to just place it on the surface you want it to go on. You know you're in good shape when you see this preview, okay? If you don't see the preview, something's not set up right. So I'm just gonna go there, and now you're gonna notice that this is how it knows. So notice I touch this surface, that stopping surface goes on there, and then the orientation is the form is gonna go out the other side. Does that make sense? If I turn this around and I put it on this side, then it's gonna go to the inside, okay? And then once I say, okay, here, that's what you want. Now you're gonna notice that it placed it. I'm gonna do it one more time. If I go in, let's see, where's it? The side bump. So if I go in right here, all right, and you'll notice that there's a position, okay? Don't do the position at this level. I played around with this a long time too, and I'm like, So what I did was I just let it sit in a random place, just like I did over here, okay? So I've got this one in. When I expand my side bump form tool, I have a undefined sketch. This undefined sketch is that position, okay? So when I click on here and I go into edit, now what it does is it just shows me the insertion point, and the insertion point is going to be the origin of your sketch, like when you made that form tool. It's going to show me the insertion point, and all I need to do is I need to just smart dimension that to wherever it needs to go, like from one edge to another here. I'm going to just leave that dimension, and then I need to do it from, let's say the side to there, from the side to there, and then I'm just going to leave that dimension. Once I have those two dimensions in place, I am now fully defined, and now that sketch is fully defined, and then I can hit exit sketch, and it's going to be in position for me. That's how I found to do all of the forms when I brought them in. I just brought it in first, put it in just a generic place, and then I hit OK, and then I went back in and I went into that second sketch and defined the insertion point, okay? So I just found that if I did it on the position tab, it just wasn't working all the time. So I was struggling with that. So that is everything that I wanted to touch on the assembly, the individual parts, as well as pulling in this form tool and the things that you have to keep in mind. At this time, does anybody have any questions about Can Crusher stuff? Okay. So then the rest of the time you have to then work on whatever you feel you need to. I'm here to answer any questions that you might have. And yeah, we'll just proceed as we need to. So I'm going to stop our recording.